Imagine standing on a beach in Antarctica. No parka, no frostbite, just warm, muggy air, and maybe a few palm trees swaying in the breeze. Welcome to the last time Earth decided to ditch the whole ice thing and go full tropical vacation mode. It wasn't a glitch. It wasn't an asteroid. It was just Earth being extra. The poles were toasty, the oceans were 200 feet higher, and crocodiles casually swam in what is now the Canadian Arctic. You know, totally normal stuff. This wasn't some prehistoric blip either. It lasted millions of years. The entire planet turned into a greenhouse fever dream, and everything from duck-billed dinosaurs to hippo-sized proto-mammals had to adapt, or get steamrolled by the climate. And here's the kicker. We didn't just learn about this from vibes and guesses. We've got receipts. Literal microscopic fossils, ancient tree leaves, and ocean mud that all scream the same thing. Yeah, the ice was gone. All of it. So let's rewind to the last time Earth looked like a swampy sauna before penguins needed tuxedos and sea levels politely stayed put. It's hot. It's weird. And honestly, it's uncomfortably familiar. So when exactly did Earth decide to melt all the ice and host a planet-wide barbecue? Twice, actually. The main heat waves came during the mid-Cretaceous, around 100 million years ago, and again during the Paleocene-Eocene thermal maximum, PETM, about 56 million years ago. And trust me, neither event was subtle. Let's start with the Cretaceous. Yes, the dinosaur era, but specifically the part where the Earth turned into a hothouse. Picture Pangaea already broken up, continents drifting apart like awkward roommates. As they moved, mid-ocean ridges got extra active, pumping out brand new crust and, more importantly, releasing a ridiculous amount of CO2. Combine that with major volcanic eruptions, like the Ontong Java Plateau kind of volcanic, not just a single Mount St. Helens, and you've got yourself a climate system marinating in carbon dioxide. And carbon, it turns out, is Earth's favorite space heater. Atmospheric CO2 during the mid-Cretaceous may have topped 1,000 parts per million, nearly 3 times today's levels. That's not just a warm day in Florida. That's a rainforest in Wyoming kind of situation. Ice? Never heard of it. The poles were more beach resort than frozen wasteland. And the ocean? Think bathtub warm, which is fantastic for sea reptiles and giant ammonites, but less ideal for, not drowning entire coastlines. Fast forward to the PETM, and things got even weirder. Earth had just barely recovered from the dino extinction, and now it's like, hey, let's do another heat wave, this time with mammals. Around 56 million years ago, something, possibly volcanic activity from the North Atlantic igneous province, or methane released from ocean sediments, sent another huge pulse of carbon into the atmosphere in just a few thousand years. That's fast. By geological standards, like blink and everything's on fire, off fast. Temperatures rose between 5 to 8 degrees Celsius globally, which might not sound like much until you realize it made the deep ocean hotter than today's surface waters. That's not just warm. That's, you can scuba dive without a wetsuit in the Arctic. Warm. And what about the poles? In both the mid-Cretaceous and PETM, the Arctic and Antarctic were lush, ice-free, and, brace yourself, possibly home to swamps and forests. Crocodiles, turtles, and even tropical plants were thriving at latitudes that today would give them hypothermia in 5 minutes. So yeah, ice wasn't just gone. It was unthinkable. But this wasn't just some vacation phase. It lasted for millions of years. Earth's thermostat was set to sauna, and nature just rolled with it. No polar caps, no glaciers, just endless warmth, high humidity, and coastlines doing their best disappearing act. And here's the kicker. This whole climate chaos was caused naturally. Slow burn CO2, buildup from volcanoes, tectonic changes, and the occasional massive methane burp. No SUVs, no cow burps, just geology being dramatic. But as we'll see later, we're now doing it way faster. A planet with no ice. So, what does an iceless Earth actually look like? Short answer: sweaty, soggy, and slightly unhinged. With CO2 through the roof and the poles toasty, Earth in the mid Cretaceous and PETM wasn't just warm, it was weirdly warm. The equator still baked, but the real surprise was up north. Picture Arctic rainforests, swamps in Siberia, crocodiles chilling, well, not literally, in what's now northern Canada. Antarctica, a haven for ferns and freshwater lakes. Penguins wouldn't even recognize the place. Sea levels were a nightmare, up to 200 feet higher than today. That's enough to drown Florida, most coastal cities, and a generous chunk of the Midwest. The continents looked completely different. Shallow seas, flooded inland areas, turning Kansas into beachfront property. Sorry, Dorothy, not going back to the farm. The oceans, now warm from top to bottom, didn't mix well. Without cold water to sink, circulation slowed. Oxygen levels plummeted, especially in deeper zones. Result: massive dead zones and black shale deposits from all the organic gunk piling up. Not great for fish, fantastic for future oil companies. Coral reefs weren't suffering, though. They just packed their polyps and moved closer to the poles. Same with mangroves, turtles, and all sorts of heat-loving creatures. Life didn't die off. It just adapted to the swampy vibes. On land, rainforests exploded in places that today are basically deserts. Wyoming, jungle, Arctic Canada, lush and green. Everywhere had that sticky post-thunderstorm feeling. Constant humidity, no real winter, and storms that probably made modern hurricanes look like light drizzle. This was a planet turned inside out. No ice caps, no chill. Literally. And life had to deal with it. Now, if you're thinking a steaming, iceless Earth was just palm trees and pretty sunsets, think again. This place was crawling, stomping, and swimming with some of the weirdest, sweatiest, and frankly, most out-of-place animals you can imagine. Let's start with the Cretaceous, Dinosaur Central. You'd think the poles would be off limits for cold-blooded giants, but nope. In what is now Alaska and Antarctica, you had hadrosaurs waddling through polar forests and raptors skulking around like overgrown snowy owls, minus the snow. These weren't your average reptiles. Some had feathers, some had heat-retaining body plans, and all of them were basically living proof that even dinosaurs were like, screw Florida, let's head north. And they weren't alone. Turtles, crocodilians, and lungfish were thriving in freshwater lakes above the Arctic Circle. That's right, crocodiles in the Arctic. It's not just a fun mental image. Fossil sites like Canada's Axel Heiberg Island back it up. The place had giant turtles the size of bathtubs and alligator-like champsosaurs just vibing among the redwoods. Try picturing that while shoveling snow in January. Fast forward past the asteroid, and things get even weirder during the Paleocene-Eocene thermal maximum. Dinosaurs are gone, but mammals are getting their big evolutionary break, right in the middle of Earth's worst hot flash. Imagine early primates leaping through steamy rainforests in what's now Colorado. Tiny, tree-hugging mammals like Plesiadapis adapting to tropical ecosystems thousands of miles outside the tropics. And then there's Coryphodon, basically a hippo, mixed with a wombat, stomping through Eocene swamps in the high Arctic. It didn't hibernate, it didn't migrate, it just lived year-round in a place where there should have been glaciers. Instead, it had mossy forests, balmy winters, and possibly even seasonal darkness, without the cold. That's a whole new level of weird. Marine life was also getting a suntan. Sharks, early whales, and giant marine lizards like mosasaurs ruled the bathtub oceans. With tropical temperatures creeping into today's temperate zones, warm water species had an all-access pass to the poles. And without ice to lock up water, those oceans were deeper and broader, with epicontinental seas turning whole continents into island chains. Coral reefs flourished in what's now the Arctic Circle. Mangroves moved hundreds of miles north. It was basically a prehistoric beach party, unless you were a deep-sea critter. The deep ocean got stuffy, oxygen poor, and acidic. Great for organic muck. Terrible if you had gills. This wasn't some minor shift. This was an entire biosphere flipping its usual map. Cold zones became tropical, deserts got wetter, and every creature had to play climate roulette. Some, like crocs and turtles, loved it. Others adapted fast or vanished quietly into the fossil record. And here's the wild part. They didn't need thousands of years to evolve into new forms. Many just moved. Ecosystems rearranged themselves, migration paths stretched across entire continents, and animals just followed the heat like it was the world's slowest moving summer vacation. Okay, so Earth was already running hot. But then came the Paleocene-Eocene thermal maximum, basically the planet's version of a panic attack. This was not your everyday warm spell. This was climate chaos on steroids. It kicked off around 56 million years ago, and we still don't know the exact trigger. One theory? Massive volcanic activity under the North Atlantic, cracking open the seafloor and releasing insane amounts of carbon. Another? Methane hydrates, basically frozen methane locked under ocean sediments, suddenly thawing and burping their contents into the atmosphere. Whatever lit the match, the result was the same. Global temperatures jumped by 5 to 8 degrees Celsius in a geological blink. That might sound mild until you remember, this happened over just a few thousand years. For Earth, that's light speed. You could basically track the temperature rise layer by layer in ocean sediment. Boom! Carbon spike. Boom! Acidified oceans. Boom! Species freaking out. The oceans got hit first. CO2 dissolving into seawater made it more acidic, messing with marine life like foraminifera, those tiny shelled critters that form the base of the food chain. Many of them didn't make it. Their fossil record shows a dramatic drop in diversity. The ocean was literally dissolving the shells off its own inhabitants. On land, mammals started shrinking. Not metaphorically, literally. Species like Siphohippus, one of the earliest horses, shrank to the size of a house cat. Why? Possibly to deal with overheating, or maybe because food quality tanked under the new tropical conditions. Either way, evolution hit the fun size button. Whole ecosystems shifted. Tropical rainforests pushed into higher latitudes, desert zones expanded, and species that couldn't migrate fast enough or adapt, gone. Extinction rates ticked up, especially among marine organisms and temperature-sensitive groups. And yet, despite the chaos, this wasn't the end of life. It was more like nature getting slammed by a truck, then standing up and adapting, shakily. Forests grew back in new places. Mammals diversified, fast. Primates spread into new territories, giving your great-great-great-Grand Lemoore ancestors a fighting chance. But here's the haunting part. This is the closest natural comparison we have to what's happening now. The PETM was a carbon dump of epic proportions, and yet the rate of carbon release then was about 10 to 20 times slower than what we're doing today. That's right. We're speedrunning Earth's worst hot flash. The PETM also took at least 100,000 years to cool off. So even after the carbon stopped pouring in, the climate didn't magically reset. It took time. A lot of time. And that's the big warning sign hanging over us like a very sweaty cloud. The fossil record tells us that Earth can survive extreme warming. Life adapts. Ecosystems bounce back, eventually, but for the species caught in the middle of it, the view isn't so rosy. After millions of years of sweating it out like a planet stuck in a greenhouse, Earth finally decided to chill. Literally. But the cool down wasn't some dramatic flip of a climate switch. It was more like a long, slow exhale after a panic attack. And it took a while. The big cool down started around 34 million years ago, in the late Eocene. By then, Earth was tired of being a sauna, and several big geological events gave it the excuse it needed to start making ice again. First major plot twist: India slammed into Asia. Not great for either continent's personal space, but fantastic for climate. The collision created the Himalayas, and all that fresh, raw rock started sucking CO2 out of the atmosphere through weathering. Think of it as Earth installing a giant natural carbon vacuum cleaner. Over time, atmospheric CO2 levels dropped significantly, possibly down to under 500 parts per million. Then there's Antarctica, our favorite frozen continent. Back in the hot days, it was more like a swampy vacation island, but as the continents kept drifting, it moved farther south, right over the South Pole. Once it was isolated enough, a cold current called the Antarctic Circumpolar Current formed around it. This basically wrapped Antarctica in a freezing water blanket and let it start building up ice. A lot of it. We're talking permanent ice sheets for the first time in tens of millions of years. And once Antarctica iced over, global temperatures took a noticeable dive. The ocean circulation system changed too. Cold, salty water started sinking again, which helped oxygenate the deep sea and cool things off even further. It's like Earth finally fixed its broken thermostat. Meanwhile, the Arctic took its sweet time. It didn't start accumulating significant ice until much later, around 2.6 million years ago, kicking off the Pleistocene Ice Age, the one that brought us glaciers, woolly mammoths, and your uncle's obsession with Ice Age documentaries. So the re-icing wasn't just about temperature, it was about geography, ocean currents, and plate tectonics all aligning to create the perfect conditions for snow that didn't melt in summer. Once polar ice was back in business, sea levels dropped dramatically, ecosystems shifted again, and Earth entered a long period of on and off glaciations, the kind where ice advances and retreats like a slow-motion dance battle. And unlike the hothouse world, this icy Earth shaped everything we know. It influenced human evolution, agriculture, and modern coastlines. No more crocs in the Arctic, no more jungles in Wyoming, just a frosty, somewhat more familiar planet. But here's the thing. All it took was a few major plate movements and a few million years of rock, grinding down CO2 to shift from palm trees at the poles to glaciers bulldozing New York. And now we're reversing that so much faster. So how do we even know Earth once hosted crocodiles in the Arctic and rainforests in Wyoming? It's not like there's a giant stone calendar that says 56 million years ago, global heat wave. Instead, scientists have pieced together this prehistoric sauna story using some of the most hardcore detective work in science, minus the trench coats, plus a lot more mud. Let's start with the unsung heroes of climate forensics. Foraminifera. These microscopic, shelled plankton live in the ocean and are basically floating thermometers. When they die, their shells settle on the seafloor and get buried in layers of sediment. Those shells are made of calcium carbonate, which locks in oxygen isotopes, specifically the ratio of oxygen 18 to oxygen 16. That ratio shifts depending on the temperature of the ocean. More O16? Warmer water. It's like nature's own climate data log. Scientists drill deep into ancient ocean sediments, pull out cores, and then go full CSI on the forums. From this, they can reconstruct global temperature trends going back tens of millions of years. It's precise, it's nerdy, and it's kind of amazing. On land, we've got leaf fossils playing a similar role. Fossilized leaves can tell us what the atmosphere was like, because plants are picky. Certain shapes and edge patterns only appear in specific climates. Smooth-edged leaves, usually tropical, jagged or lobed, more likely to show up in cooler zones. There's even a method called CLAMP, Climate Leaf Analysis Multivariate Program, which basically turns leaves into climate charts. Then there's the carbon evidence. During the PETM, there's a huge negative carbon isotope excursion, a fancy way of saying a ton of light carbon, aka methane or volcanic CO2, suddenly appeared. This shows up in both marine and terrestrial records. It's like a bright red flag in the geologic timeline that screams, "Hey, massive carbon release happened here." Even coal deposits and ancient soil layers, paleosols, get in on the action. They help track CO2 levels over time by revealing how much vegetation was around and how carbon was cycling through ecosystems. And then there are the fossils themselves. When you find crocodilian skeletons in the Arctic Circle or tropical wood buried under Antarctic ice, it's not subtle. These animals and plants had very specific temperature requirements, and they didn't survive long-term freezing. Their presence means those regions had to be way warmer than they are now. In some areas like Ellesmere Island in Canada, paleontologists have uncovered entire ancient forests, fossilized tree stumps still rooted in place. Some even have growth rings showing year-round growth, with no sign of a freezing season. It's like finding a perfectly preserved jungle in your freezer. All these clues build the case. Earth wasn't just warm, it was radically, globally, systemically hot. And every bit of data, every leaf, shell, and mud layer tells the same story. But the coolest or hottest part is that all this ancient evidence isn't just about the past. It's a mirror, a climate time machine, a warning wrapped in limestone. Because if we want to know where we're heading, we have to look at where we've already been.